So, my apologies again for today's lecture. I wasn't as prepared as I thought I was. I figured out that what was happening was something had gone wrong with Quartus and it wasn't actually doing what it was supposed to be doing. Restarting it seems to have fixed it, so I thought I'd record how to use, say, the counter to out of the library to do that division by 50 million. Right, so I'm just going to create a new project, and let's call it second LPM example, and I'm just going to call the name of the project as well second LPM example, and we'll keep that as the top level entity. That should be okay. And we'll create a new directory, and it's an empty project. There's no files I want to add to it. I need to get the C8 variant from the list of devices, so let's just scroll down and get that C8. I need to select Model Sim Altera VHDL. Okay, and that's everything we need to do. So then we have a new project. So there's a couple of ways you could do it. The way I'd suggest doing it is going into the IP catalog, right, and going into arithmetic and scrolling down to LPM counter. Double clicking on that, and making sure we select VHDL, just because we were interested in VHDL. I'm going to make a new device based on this called my LPM counter. Okay, and we do that, and if you remember correctly, we needed 26 bits, and we wanted a modulus counter of 50, 1, 2, 3, 1, 2, 3, 50 million, and everything else is perfectly okay. I'm going to select all of the outputs just because I like to see everything that it generates. And now we should have a something that we can build with. Now it's not exactly clear where that is, so let's just make a new, and I'm going to do the block diagram approach. Right, so, and then I can go insert symbol, and if you scroll up here, there's now a project section, and there's my LPM counter, right? And I can drop that there, and that should do the right thing. Now I need to connect up some I/O to it, right? And so I'm going to insert another symbol, and I'm going to go down here to primitives and pin, and I want an input, right? And I can try and line that up there, and I'm going to call the pin clock because it's a clock, right? Now for the other side, I don't actually need all 26 bits coming out here, right? So what I do is I pull that out and I label it, but just by pulling it out so that it's selected, you can see it's highlighted in blue rather than purple, and then just type Q open square bracket 25 dot dot 0 close square bracket. No spaces, no nothing. Now we have a labeled bus. This is a bus of 26 values that are coming out, numbered 25 down to 0. Now what I can do with an output pin is I can select that output pin and I can put it there, and simply by naming the output one of those outputs, right, one of those Q values, and I'm just going to pick the most significant bit, that's the one that's changing the least often, I can select that out, and now I should be able to save that, and I think I want to call it my LPM example. It already does that, And now let's see if that compiles. I'm hoping it compiles. Right? And I might have to compile it again, because one thing I've forgotten to do is to do the pin planner. So while that's compiling, I'll pull it up. Oh, we haven't compiled it yet, so we don't have any pins. Okay, so we do have to get it to compile. Okay, we should have 2 pins. We should have an input pin and an output pin. There they are there. Remember, the clock is pin 23, and one of the LEDs is pin 87. Eek. I don't know why it went over there. I'm going to put that in there and put that in pin 87. Okay, and now I've connected my design to the actual output on the board. I now need to compile it again to make sure that those connections are set up in the file that I want to download to the device. And just remember why I'm using that, if I can figure out where the right, here's the oops, let's just throw that off the screen and throw that screen there. Right, remember my FPGA clock is pin 23 and LED 1 is pin 87, right, from last time. Okay, it's just about finished compiling. Looks like it has finished compiling. Now what I can do is I can open the programmer and hit start, and we should be able to see the device working. And of course it's not, even though it did when I did it before. So let me just see if I can figure out quickly what the problem is. Aha, look at that, it's not connected. For some reason that hasn't connected up to the clock. And it looks like it's connected now. Okay, the clock wasn't connected. And you can see now that I have actually done the pin planner, it's set those up. So let's just recompile now that the clock is actually connected to the input of the device. That might help, mightn't it? Of course, nothing ever goes quite the way you expect. So let's just get that compilation finished. Okay, now we can open the programmer again and download it. And yes, so here's the board, and you can see that it is this time actually doing a division by 50 million. So the LED is on for half a second and off for half a second. It may look a little bit like it's more on than off, but that's probably because of the blooming that's happening on the camera. The LED is actually very bright, and the camera is blooming. So it's what's the word? Saturating. Okay, so that actually seems to work correctly.